Spectrofluorometer. The power supply is what supplies the power to the entire spectrofluorometer. The white tube there coming off of the top of this power supply is what cools down this lamp, our source, the xenon arc lamp. This source fires radiation through that tube into a wavelength selector. The wavelength selector shown here will take that radiation source and select one wavelength set for excitation of the sample. The sample holder shown here is what holds the cuvette which the sample is in. As you can see from that open port in the back, that is where the wavelength will come through and excite the sample. Once the sample is bombarded with the radiation, the analyte will jump to an excited state. Upon being in the excited state, it will relax back down, giving off fluorescence, which will then go through the tube right there to the right side or left from this view, and from that tube it will then go into the wavelength selector number 2, where this wavelength selector will select the appropriate wavelength that gives the maximum reading of emission from the fluorescence. Because the fluorescence is not very intense, we need a photomultiplier tube to act as an amplifier on our signal. This will increase the strength of our signal, which will then go to our signal processor. The signal processor will take all the electrons and convert them over to something that humans will actually be able to understand once they reach a readout device, which will translate this into a graph which gives you intensity. This intensity is from the fluorescence. Calibration. To calibrate the spectrofluorometer, the first thing you will need to do is prepare a blank solution. The blank solution will contain everything that the normal standard would, except the analyte. This is called the matrix. When you run this blank, you will obtain a baseline reading which contains the noise. This will be subtracted from any other reading you take to obtain a noise-free reading. The next step in calibration will be finding the optimum excitation and emission wavelengths. This is simple by setting the machine to scan your analyte for the excitation and emission wavelengths. Once you get that spectra, you will simply use the peak of both wavelengths. These peaks will give you the best and most intense fluorescent readings possible, which can be very bright. Create 7 standards with increasing concentration of the analyte. You will then run these on the instrument and obtain a regression line, also known as a calibration curve. This regression line will then be used to obtain any unknown sample's concentration. Solvent. The most common solvent used is simply water, deionized water. Sample injection onto the instrument. First, you need to pipette the unknown sample into the cuvette. Fill the cuvette up about 3/4 of the way full. Then place the sample into the sample holder. To ensure no stray light or fluorescence is lost, close the lid. Oh wait, not that lid, but the one that encloses the sample. To remove the sample, simply take the cuvette out of the machine. What do we do with the numbers the instrument gives us? When the instrument reads out an intensity, the experimenter should take note of this intensity. To get meaningful analysis of this number, plug it into your calibration curve's regression line. That function will translate the intensity to a concentration of the analyte present. The intensity also tells you a chemical characteristic of the analyte, that it does indeed fluoresce. If the intensity is lower than thought, there could be interferences present, such as a quencher, which provides an alternative route to relaxation.